See, the difference between myself and most people is that when most people saw this play happen, they thought, wouldn't Mike Tomlin be suspended? But when I saw this play happen, I thought about related rates and calculus. I thought, what if Jacoby Jones was a lamppost? And what if Mike Tomlin was walking at a certain rate of speed away from that lamppost? I want to know, at what rate was the tip of Mike Tomlin's shadow moving? And at what rate was Mike Tomlin's shadow growing? Now, luckily, I can apply this to a question in calculus that we went over. Number 33, section 3.7, related rates. The question reads, a man 6 feet tall walks at a rate of 5 feet per second away from a light that is 15 feet above the ground. So we have to draw our figure. A lamppost is 15 feet above the ground, and Mike Tomlin, we're going to pretend he's 6 feet tall. Now we know from the lamppost to Mike Tomlin, we're going to call that X. And from Mike Tomlin to the end of his shadow, we're going to call that A minus X. And because we call that A minus X, we're going to call from the lamppost to the end of his shadow, A. So reviewing what we've been given. Mike Tomlin, he's 6 feet tall. Alright, so you want to write that out, make sure you have everything. The lamppost is 15 feet tall. Okay? And now, given in the question, it says a man 6 feet tall walks at a rate of 5 feet per second. Okay? So that's when Mike Tomlin springs into action. dx over dt, that's how fast he's walking, is 5 feet per second. So again, you want to write that out. Now, question A reads, when he is 10 feet from the base of the light, at what rate is the tip of his shadow moving? So write it out. X, from the post to Mike Tomlin, is 10 feet. Alright? So doing question A here. We want to make a proportion. We'll make 6 over 15, which is the height of Mike Tomlin over the height of the lamppost. That's going to be set equal to, there we go, in parentheses, A minus X over A, which is the shadow length over the full length. Alright, and now 6 over 15, I catch up here. 6 over 15 reduces to 2 over 5, which is equal to A minus X over A. Now you want to multiply 5 on both sides. So that is going to give you 2 equals 5A minus 5X over A. Of course, you want to get A out from the bottom, so multiply that by both sides. And you come down here, end up with 2A equals 5A minus 5X. Alright, and you want to get the same variables, on either side. So 5X moves over, 2A moves over. You end up with 5X equals 5A minus 2A, which equals 5X equals 3A. Then, of course, you want to clean that up, divide 3 on both sides. A is going to equal 5 over 3x. Now, we want to find the rate of this. We want to find the rate of the tip of the shadow. So, A becomes dA over dt, and x will become dx over dt. Now, we know dx over dt, that equals 5 feet per second. We get that in the problem at the top there. So you plug that in. dA over dt is equal to 5 over 3 times 5. And that's going to give you the answer to question A. How fast is the tip of a shadow moving? So dA over dt is equal to 25 over 3 feet per second. Okay, now on to question B. B says, when he is 10 feet from the base of the light, At what rate is the length of his shadow changing? Okay. So we're not trying to find the tip anymore. We're trying to find the length. And we know that the length, that is a minus x. We did that when we drew out the diagram. Okay. So we need to differentiate this to find time, just like we did in the last one. D parenthesis a minus x, close parenthesis over dt. You want to distribute the d on the top, so that equals dA over dt minus dx over dt. And now we know what both of these values are. In question A, we found that dA over dt is equal to 25 over 3 feet per second. And we know, there you go, you can see. And we know from, in the given problem, that dx over dt is equal to 5 feet per second. Okay, so we plug those in. 25 over 3 minus 5, that equals 25 over 3. The 5 is multiplied 3 times, so you can get the same denominator. So 25 over 3 minus 15 over 3. That gives you your answer to problem B, which is 10 over 3 feet per second. And that is the rate in which the length of his shadow is changing. And that's it.